the first question here is not like rocket science. I think just make sure you get the 3 marks there. So given that n is an integer, find Zn over W conjugate in terms of n, give you answer in REI. Okay, great. So first thing, we just need to find the modulus of Zn here. So modulus of this would just be Zn over, then this will just be Zn over W, which is actually just mod Z is 2, argument Z is pi over 8, W is 1 plus I, so argument of W is root pi over 4, right? So you see W, I'm just going to write this out. If we write down W, I'll just draw it out, W out for you, okay? But if you can visualize it, just do it. It's faster to know that it's just 45 degrees, okay? I'm doing this slowly. So this is W. This is pi over 4. See that this is 1 to 1. Now the ratio is 1 to 1. You get the exact argument. So argument W is pi over 4. Modulus W is just root 2 lah. Okay. So this will just be mod Z, which is actually just 2 to the power of n. W will be just root 2. So this is 2n minus half. Root 2 is the power of half. So I just leave it as 2n minus half. Then argument of Zn W conjugate behaves like logarithm. Argument Zn minus argument W conjugate. And argument Z will just be pi over 8. Z conjugate will just be negative of argument W. There will be pi over 4. Okay, there you go. To make it nicer, we can just factorize the pi out. So Zn 2n minus half ei pi . Yay, great job. So for the second part, hence find the smallest positive integer n such that this argument, complex number here is real and negative. Real negative just means is what? Negative real number lah. Okay, that's about it. You need it to be real and negative, meaning to say, now how a number behave is determined by its argument, pre-eradicated by the argument. So you just write down argument Zn W, just the general form. Okay, so this is what I'll do. I usually just draw the argument diagram here, and I just decide what do I want. I just want it to be negative real. Negative real is this axis here, this side here. So this one here is actually just pi. The general term is just pi plus 2k pi. You need to be all encompassing. You need to encompass everything out of the principal argument. That's why you need the general term. So this is what you must be able to write. That's why I say don't list down the angle. You list down angle is not efficient, okay? So that's about it. Now once this is done, you know the argument of this, okay? The argument of this number here is actually just this over here, which we found just now. Just put it in, then everything will be nice ready. So this is n over 8 pi plus 1/4 pi equals to pi plus 2k pi. Okay, so once this is done, just cancel all the pi. Everyone has got the pi, just cancel the pi. Make sure you cancel it nicely. So it's n over 8 plus 1 over 4 equals to 1 plus 2k. Multiply by 8. Actually, you can just do whatever you want to do here lah. So I'm not gonna tell you what to do. So this is 3/4 plus 2k. So n is equals to 8. 8 times. Just make n the subject. I think this one sec 1 stuff, so I don't think it's like So the n is equals to 16k. Okay. 2 positive integer. Find the smallest 2 positive integer. Okay. So k is all k is all integers. K is so the smallest integer will be when k is 0 lah. N is 6 and 22. Yeah, 6 and 22. Okay. You just key into calculator, you will see lah. This k here. I'm actually observing by looking at the k ranging from negative as an integer value. The smallest positive n would be when n is 6, when k is 0, and k is 1. The next smallest will be 22. So you just key in calculator here. This would be 6 plus 16k. Second table, 6 and 22. Okay. Anything other than that is like negative and so on. So these are the 2 smallest. So from GC, this is k, this is 6, this is n. Okay, the smallest 2 will be this and this one. So let me just write this down. Smallest, 2 smallest positive integer n.